The devil is always in the details. It always is. And when it comes to application security, it's no different. It's 2021 and we have more detailed security and breach data than ever, given the multitude of tools and solutions that are employed worldwide to scan for security issues and alert us of potential breaches. Then how is it that the state of application security is still so dismal? I argue that a part of the reason is the fact that no application is actually built the same, and each application actually presents an entirely different attack surface. Moreover, the application today is also polymorphic, from web to mobile to APIs, making application security a multidimensional challenge sometimes. But there's potentially another reason here, a reason that we can address with a little bit of effort. The reason could be the fact that we do not look at the data in front of us for answers. We often end up using AppSec data to justify a conclusion or a want in the business, whether it is the want for more budget or justifying a delay in time to market for an application. We seldom look at this data to find insights that may actually drive us to a different conclusion. So the question is, can we look at data differently in 2021 with an eye towards finding new insight rather than justifying a conclusion?
Welcome to White Hat Security's AppSec Stats Flash, the monthly podcast on the state of application security. Hosted by Setu Kulkarni with analysis from White Hat's in-house security expert, Zach Jones. Today's special guest is Alan Snyder, CEO of Now Secure.
Welcome to the AppSec Statistics Flash for February 2021. For those tuning into this podcast for the first time, let me give you a quick summary of the why, what, and how behind this AppSec Stats Flash. Now, the threat landscape around applications today is evolving at an unprecedented pace. And at the same time, we are pushing more applications into production than ever before. In the light of these two trends, we want to take a continuous and a contemporary look at the detailed AppSec data that we are generating with every passing day. This AppSec Statistics Flash is a monthly analysis of the detailed AppSec data we have, but more importantly, it endeavors to look at this detailed data to find new insights that may lead us to meaningful conclusions. As usual, I'm joined today by Zach Jones, who will help us parse the data we see and tease out the insights. You can also download the February report from the show notes. Starting this episode, we are taking a more nuanced look at our data. Broadly, we're examining the detection data, meaning what are the vulnerabilities we're finding, using a 3-month rolling window. And we're examining the remediation or mitigation data, meaning how is the world reacting to the issues that we discover, using a 12-month rolling window. The reason in our mind is pretty simple. The current time frames for remediation or mitigation are so large that looking at a rolling 3-month window is not meaningful enough. At the same time, the threat landscape continues to evolve as more applications are being pushed to production. So it really makes sense to look at vulnerability detection in a shorter rolling time frame. With that said, let's get into the statistics for this month. As usual, we'll start off with window of exposure, basically a metric that tells us how large the window of opportunity is for the adversary to compromise an application. Now, we continue to see the trend from last month, which is an abnormally high window of exposure for industries like manufacturing, public services, healthcare, retail, education, and utilities. The bottom line here is that as more industries pivot to becoming online first, there has to be an increased focus on AppSec. The current state of affairs is pretty bleak in that at least 50% of the applications in these industries that I outlined are vulnerable throughout the year due to one or more serious exploitable vulnerability. Next, let's turn our focus to vulnerability likelihood. Now, remember, we are examining vulnerability likelihood using a 3-month rolling window. What we find is that the composition of the top 5 most likely vulnerability classes is fairly static. But among those 5 vulnerability classes, the likelihood changes from month to month. The net takeaway here is that the top 5 vulnerability classes are the classes to focus on a constant basis. And for teams, you should start focusing on mitigating these vulnerabilities with priority. Go ahead and download the report for a detailed list of these top vulnerabilities. Now, what I want to do is, with that broad backdrop, I want to dig deeper into these top vulnerabilities using a fairly well-known lens, the lens of the OWASP top 10. What is the correlation between what we find, what we see, and what the OWASP top 10 lists? After all, my argument is that OWASP top 10 is almost always the starting point for AppSec discussions. Whether you're a developer or a security operator, you start with OWASP top 10. So let me bring Zach in at this point. Zach, what can we say about, let's say, the white hat top 5, if I may call it that, and the OWASP top 10? How many of the most likely vulnerability classes that we see actually feature in the OWASP top 10?
So what we see in terms of the detection landscape at White Hat is that out of our top 10 most common detections of any risk, 5 of those classes are not represented by the OWASP top 10. And then if we filter on serious risk vulnerabilities, 3 out of White Hat's most common top 10 detected vulnerability classes are not represented in the OWASP top 10. So we have some interesting differentiation between the educational tool of the OWASP top 10 and the vulnerabilities that we are seeing being most likely detected in the applications that our customers ask us to assess.
So you're saying OWASP top 10 could be a good starting point, but we should really calibrate our actions against the actual vulnerabilities that show up in the applications when they're scanned.
Absolutely. The OWASP top 10 itself talks about being a first step in awareness of application security and vulnerabilities related to applications. But at White Hat, we want to advocate an approach of, sure, take the first step, but let's also take the second step and the steps going forward. And I think in order to do that, we have to look at the actual detection likelihoods and come up with more granular views of the vulnerabilities that various profiles or personas within an organization need to have a detailed understanding of, be monitoring, and be concerned about.
Okay, let's then dig a little deeper into this, Zach, because I think there might be a proverbial DevSecOps aha moment here. Let's zero in on the most likely vulnerability class, which is the insufficient transport layer protection that we find, and it maps into the OWASP top 10 against the A6 security misconfiguration classification. Can you break down what A6 is? Because I suspect A6 is a broad classification, and insufficient transport layer protection is one of the vulnerability classes that makes up A6. So why don't you break down A6 for us, please?
Absolutely. So the 2 headline white hat vulnerability classes that we detect commonly that map, as you said, the most common is insufficient transport layer protection. And the second one, especially from a risk lens perspective, ends up being directory indexing. And so we see that the combination of those 2 white hat vulnerability detections really make up the majority of security misconfiguration detections when we're lensing through the OWASP top 10. So we see around 68% likelihood of any site having a vulnerability that maps to OWASP A6. And out of that, if you look at the white hat insufficient transport layer side, you see that just insufficient transport layer protection by itself has a 60% likelihood of being detected on any given site that we scan. So that grouping, that class of security misconfiguration being a general headline class, really has an outsized representation in terms of a single vulnerability class, insufficient transport layer protection, really weighing it and causing it to be so common.
Right. It's interesting because when you look at insufficient transport layer protection, you said it's almost 60% of the representation within the A6 OWASP classification. Let's try and break that down a little further, right? As I look at this data of all the insufficient transport layer protection vulnerabilities, it's clear that there are some vulnerabilities within that vulnerability class that are security control type vulnerabilities and some that are purely code vulnerabilities. But what's interesting is the vast majority of the vulnerabilities that make up insufficient transport layer protection, almost 33%, are really HTTP strict transport security vulnerabilities, right? So that one particular vulnerability, HTTP strict transport security vulnerability, makes up 33% of all the insufficient transport layer protection vulnerabilities reported, which make up almost 60% of all the vulnerabilities reported overall. So what is this vulnerability, Zach, the HTTP strict transport security vulnerability? How do we avoid it? And because this vulnerability straddles both dev and security, is there a DevSecOps takeaway here?
HTTP strict transport security is really an opt-in security enhancement that was first published near the end of 2012. And it allows sites to do a couple things. It allows them to really specify a greater level of control with regard to things like allowing users to click through warnings about the site's transport not being secure, or basically disallowing them to do so. And it also prevents certain types of man-in-the-middle attacks that previously were not prevented by TLS. So if we look at a user being intercepted the first time that they connect to a site, or if they've incorrectly bookmarked the site and bookmarked it as an HTTP site rather than an HTTPS site. This security control, HTTP strict transport security, enables the server to instruct the browser to never request the website without the communications being encrypted. And that provides that additional layer of protection for users of the website. Now, like you said, it's an interesting class. It's interesting that it's so prevalent amongst our insufficient transport layer protection vulnerabilities, because we do see a divergence in the two subtypes of insufficient transport layer, where you have the infrastructural controls versus the code level controls. And there's a real disproportionate prevalence where the configuration level controls seem to be much more prevalent than the code level issues with regard to this overall vulnerability class. And the interesting thing about HTTP strict transport security controls is that they can be implemented either way. You can add these headers at the code level of the application, or you can add these headers using infrastructural controls like reverse proxies to intercept the traffic and add the headers on behalf of the endpoint server that is providing the application features. So the fact that a vulnerability, the most common class inside of insufficient transport layer protection, sort of straddles the two kinds of controls that we see, I think potentially points to an ownership confusion issue, right? It seems that in the cases where the transport layer controls can only be implemented at the code level, overall, either the frameworks or the developers who are using those frameworks are doing a decent job of using those controls. It seems that at the configuration level, we're seeing less success, we're seeing less hardening, but in the merger, we're seeing an even greater risk profile, an even greater lack of the control being used. So it could be that case that maybe the devs think that ops is handling it, or the security team is handling it, and maybe the ops and the security team think that the devs are handling it. So there's an interesting convergence there of concerns that may not be being addressed. On the flip side, I think there's really an opportunity here with regards to DevSecOps, which is that modern infrastructure as code frameworks and paradigms are allowing these sorts of controls to all exist at the code level, or something like the code level, right? Living in the repository. So we might have our server configurations headers, reverse proxies, all of these controls now in one place so that a cross-functional team can all be looking at the same ball whenever they're deciding how to harden their security configurations.
Thanks, Zach. That was a fun deep dive, don't you say? Especially trying to do it without slides. I think the key takeaway from this discussion is really threefold. One, OWASP Top 10 is a good starting point, but we should, like I said earlier, calibrate our actions against the actual vulnerabilities that show up in our applications. The second takeaway here is that OWASP Top 10 classifications are at varying levels of granularity. For example, the one that we're talking about today, A6, security misconfiguration, is almost like an aggregate classification, while A7, cross-site scripting, is a very specific classification. So as an example that we use for A6, it becomes really critical to dig deeper into each one of these classifications to find those real opportunities to improve the overall security of the application. The final, more tactical, more narrow takeaway from today's conversation is really that for A6 security misconfiguration, a good place to start is to look at the HTTP strict transport security vulnerabilities that have been reported. There's a good opportunity for some DevSecOps collaboration there. All right, let's bubble back up. We did quite a deep dive, so let's bubble back up and look at the final metric that we should talk about today, time to fix by risk level. In my mind, this is a bellwether metric from a security posture point of view. This metric helps us track whether we are fixing the most serious vulnerabilities fast enough and thus reducing the overall window of exposure for the application. Now, this month, there is some good news in that we see a 5-day improvement in time to fix for critical vulnerabilities, which, by the way, is still very high. The time to fix for critical vulnerabilities this month around is 189 days versus the 194 days that we reported last month. By the way, it's still a very high time to fix for critical vulnerabilities. But the silver lining here is that there is a 5-day improvement that we are seeing this month versus the last month. So Zach, let me pull you in again. Any thoughts on that improvement? Is it likely that the 5-day improvement that we're seeing in critical vulnerabilities time to fix is actually due to the fact that the time to fix for non-critical vulnerabilities has shot up?
I think that's a key question. We talked in last month's episode about trade-offs. When teams seem to be focusing on one risk level or one set of vulnerability classes, we see that the metrics around the others tend to suffer. And that certainly shows up here in this time to fix metric. I think the other question is that by definition, time to fix is measuring the vulnerabilities that were actually fixed in the time period that we're querying the data. And it's sort of a seen versus unseen challenge, which is perhaps we saw fewer vulnerabilities fixed. Therefore, the ones that were fixed could be fixed faster. And so I think in future episodes, we'll bring some more detailed analysis and try to evolve time to fix metrics that really give a view of more rolling windows and also try to bring in that quantity dimension to, are we fixing more slower? Are we fixing fewer faster? That could be an interesting lens to look at.
Absolutely. Now, when I think about AppSec, I start thinking about how apps today are increasingly polymorphic, especially with the mobile form factor increasingly becoming an unsaid requirement. It's assumed today that there's going to be a mobile application in addition to the web user experience. And that's what I want to dig into in the second half of this podcast. What is the state of mobile application security? In the second section of today's episode, I'd like to welcome Alan Snyder, the CEO of NowSecure. Now, I've had the privilege of knowing and working alongside Alan for a few years now, and I always enjoy, Alan, the sporadic, deep dive conversations we end up having. And one of the things that I really admire is your grit and determination to take an idea. I know we've spoken about many ideas, but I've seen you follow through on those ideas and actually convert them into products that hit the market. So to kick things off today, why don't we start off with your story? Talk to us about some of the important, what I like to call inflection points in your journey, the important left and right turns that have brought you to where you are today.
Thank you, Setu. I appreciate the opportunity to be here and to talk to everybody. And, I often think of my conversations as not being sporadic, but I don't have many ideas. And so when I do, I need to push them through. So to your question around inflection points, for me, when you look at the career, my biggest inflection point was being recruited away from, let's just say, a large organization to a startup. And that's where, I caught the startup bug. And ever since then, I've really been focused on enjoy creating things and growing them.
Perfect. So let's kind of get into the conversation today. One of the things, Alan, I want to talk to you about today is mobile application development. I actually do dabble in some mobile application development as a hobby on the side. Now, one of the things that I've come to realize with my amateurish experience with mobile application development is that as you're developing a mobile application, you have to wear many hats, not just to get the mobile application built, but also then go through the laborious process of putting it into the App Store. Now, if I project my amateurish experience around building apps to an enterprise mobile application development team, it's likely that there are many stakeholders who get involved in getting a mobile application out of the door. And by the way, I do think that all these stakeholders have a tough time figuring out what's the best they can do for securing the mobile application that they've developed. And I think to make matters worse, at least in my knowledge, there are really no policies that app stores enforce to ensure that the application that you put into the App Store is actually secure enough. So my first question to you is really quite simple. What is the state of mobile application security today in 2021, especially as we become a mobile-first society, Alan?
Yeah, I think fantastic question. And actually, let me give you some stats on the market, because I think that they're really important to understand to kind of put this in the bigger picture context, right? If you go look at data from Adobe Analytics, ComScore, right? And this is some of the tracking firms looking at it. What you're going to find is roughly mobile apps, as it relates to traffic, are now about 65% of total app traffic. So we've shifted to mobile really in a pretty significant way. And the reason I go through that is because what it means is mobile app security really matters to customers and their business, because that mobile app traffic is now the predominant portion of the traffic and the way they interact with customers and partners. And the big thing that we see is that, sadly, the state of mobile app security is pretty poor. And for us, when we look at security, we look at it, say it's both security and it's also privacy, right? Because the customer expects not only is the app not going to make me vulnerable to an attack, but they also expect that their personal data or the enterprise data is not going to leak and be exposed. And so we look at both. What we see in the marketplace is that the vast majority of apps both have some level of vulnerability and they have issues with data leakage and privacy. And it's hard to get that right. And the reason it's hard is knowledge and understanding, right? It's the recognition that mobile apps, they're just different from web apps. So the way that you look at them, the way that you judge security, the way that you test them, it needs to recognize the fact that they're different and take that into account.
That's an interesting distinction you made there between security and privacy. And I guess the point you're trying to make here, Alan, is that with mobile applications, it is more personal than ever before, right? Mobile applications are designed for the end user. And I guess that's the point you're trying to make in highlighting the importance of privacy along with security.
Yes, and mobile has some things that, that make it uniquely personal, such as geolocation. I carry it with me all the time. right? Why is it that I use the mobile app when I want to get a car service? Well, because that mobile app has a sensor that knows where I am and to come get me. Same thing when you start to get into telemetry from a watch or some sort of IoT band. So that mobile app, by the nature of the device, has more sensors. Therefore, it has the ability to both do more, but also collect significantly more data.
And all of that passively. So the end user may not even know that the application is actually using that information or worse still, is leaking that information.
Correct, and that you see with some of the things that Apple's doing with the ingredients label of what is this app doing? Because many times customers are happy to provide that information to the app. That's not the issue. The real issue and the question is what happens to that data beyond the prescribed purpose, right? What happens to that data beyond that? And we firmly believe that customers have a reasonable right and expectation that the apps they use will be safe and secure, and there will also be disclosure about how that data is used.
Yep. Let's kind of put a pin in that, because I think that's an interesting takeaway for us today, thinking about security and privacy together distinctly, but also creating the right level of importance around both those topics. Now, in this podcast, we like to leave listeners with actionable insight exactly like that. And that's the whole idea of putting this podcast together. Something that our listeners can keep with them, something they can remember easily. So let me ask you a fairly simple, I think it's a simple question, but it's also quite loaded. What is the one thing that in your experience, all stakeholders need to remember, right? You talked about security and privacy as topics to think about when you're thinking about overall mobile application security. But what is the one thing, if you could boil it down to one thing, that all stakeholders need to remember when developing and pushing out a mobile application from a security point of view? I know it seems like a simple question, but it really isn't. So let's try to tease out that one thing that we could leave the listeners with today.
Yeah, there's layers and layers here, but that one thing is that the mobile app is very different than the web app and needs to be treated as such. So the example, right, to pull that apart is that mobile app is resident on the device. So an attacker has access to the device and to the code that's sitting there, right? Whereas in the web app, that code is likely sitting on some back-end server and is not sitting on the local desktop. The browser does a lot of the communication security, right? Embedded. The developer doesn't need to think about that. On the mobile app, the way they're constructed, that developer is really important in terms of how you use and secure your communications and data storage. That's all up to the developer. So mobile apps, the way they're constructed, the environment they run in are very, very different from web apps. And my piece I'd say is when we see a lot of the issues, when we look at our data writ large, what we see is developers that are used to developing, right? They have the best of intentions. They're used to developing and having all these things taken care of them for the browser. When they move to mobile, in many cases, they just don't know that they have to go and lock those things down. And then they don't, which inadvertently creates privacy and vulnerabilities.
And because all those protections offered by a browser are taken for granted when you're doing web app development. And your point is you can't take that for granted when you're doing mobile application development.
Well, I'll give you a good example. If you go look at the OWASP top 10, because I think, again, it's always good to look at independent, judgment, and go look at the OWASP top 10 for web versus the OWASP top 10 for mobile. And what you'll find for mobile is, it's not until you get down to 3 or 4 where you start to get the authentication, where you start to get things that are the same, but it's basically data in motion. It is data, how I store data in the local device. It's data over the network, right? It's data in motion type things. And that's because that data in motion is all secured by the browser, not so in the mobile app.
Absolutely makes sense. Now, if I were to double click on that for a minute, is there a distinction to be made here between what I'd call native apps versus apps that are kind of browser-based. You could do that on mobile applications as well.
Yes, there's a distinction in that the native app typically has access to more services. And so you're typically going to get more of a richer experience. But for the security standpoint, both need to be secured. You need to pay attention to both. Again, when you're doing, in essence, browser-based apps on a mobile device, that looks much more like a web app. In terms of because you get the protections of the browser on the local device. So the native app actually is the one where I'd say you really need, you don't enjoy those protections that the browser provides.
Got it. Finally, let's start talking about what I've been toying around in my head. I'm trying to apply the Pareto's principle to application security generally. Right? What are the 20% of the issues that, when addressed, will resolve, let's say, 80% of the security challenges when the application is actually pushed into production? One of the things that we've started talking about, I'm glad you made the reference to the OWASP top 10. We've started talking about the white hat top 5 or the white hat top 10 vulnerabilities. These are actual vulnerabilities that we see rise to the top from a preeminence perspective when we look at all the applications that we've scanned and all the data that we have from those application scans. In a similar vein, could we try and apply the Pareto's principle to mobile apps as well? In other words, what are the handful of top vulnerabilities you see in mobile applications that, when addressed, will be significantly instrumental in improving the state of mobile application security? Do you have a vulnerability or two you would like to talk about?
Well, I'd say first off, it's the focus on the data in motion. When we look at, and you can see it in the OWASP top 10 as well, right? But when we see in our data, it's the folks didn't get their communications to the backend server properly locked down or authenticated and taken care of. And that gives me the opportunity for man-in-the-middle attacks. It's folks stored data locally and left the read-write permissions wide open and did things along those lines. It's maybe they even started out using HTTPS, but somewhere along the line made a mistake and started using HTTP. So I'd say it's all related to that data in motion. And a lot of those things, you can't find them with static analysis. You actually need to run the app. You need to see the traffic. You need to understand where that traffic goes. Another great example is you need to understand the SDKs that are in your app, because while you may know where you're sending the traffic, if you wrote the app, you don't always know where the SDKs you're using are sending that traffic, right? And you have an obligation to your customer to know and understand, right, where their data is being sent if you included that SDK in there. So to me, that, it's the data in motion, and that means running the app, dynamic testing, really understanding what's happening in that traffic.
Is there another conversation to be had here, Alan, around when you talk about data in motion? I absolutely get it. But for that data in motion, it's really data that is transacted between the client and the server in a way. And on the back end, there has to be a conversation to be had about mobile applications and the APIs that they end up using. It seems like there's a tight linkage between mobile application security testing and API security.
Unquestionably, right? Because the API is that gateway into, some enterprise or cloud service. And so, and I would argue that is actually the single biggest thing that when I look at it, a lot of folks are like, well, if you compromise the mobile app, I lose the data on the device. And those folks would be like, well, that's not that big a deal. But to me, I look at it and go, well, just like on the web, that mobile app has, in essence, via those APIs, authenticated access to that back end, whatever it may be. And so that is the piece where it's like, okay, therefore, if that mobile app is authenticated and authorized, I've got a lot of access to that back end. And so it's I don't want the front end, the mobile app breached. I don't want the APIs, my gateway into the back end breached. I need to secure both of them. Very important.
Absolutely. Well, look, I think this has been interesting, right? So we did touch upon it's interesting because we touched upon three really actionable insights here, right? One is at a higher level, when you think about mobile application security, think about security as well as privacy, because both of them are equally important, two faces of the same coin. The part that really hit home for me was when you said you cannot depend on the protection offered by the browser. So as a mobile application developer, you have to start actively thinking about all the things that the browser was doing for you when you're developing a web application. And now you've at least got to do enough to get those protections either built into the app or at least taken care of through some controls. And the final piece that I think you touched upon is if there was one kind of vulnerability that you want to look at, you want to look at vulnerabilities that are exposed with the data in motion, whether it's on the app layer or it's at the backend layer. I think that kind of sums up the conversation today. Would you agree with that, Alan?
Absolutely. Because I think keeping it simple, and what I really love about where we're at is mobile apps are actually easier to secure. You just need to get the right tools and the focus to go do it, because the operating systems, iOS and Android, were really built with security in mind, right? More so than some of the other legacy operating systems out there. So the controls are there. We just need to get people more accustomed to using them.
Absolutely. Alan, this has been fun. I'm actually tempted to extrapolate our conversation to IoT and IoT apps, but I'm going to leave that for a future conversation. Hopefully I can get you back again at a later point in time and we can have that conversation talking about IoT and IoT apps as an extension to mobile apps. Thank you so much for taking the time, Alan. It was a real pleasure.
Thank you.
To our listeners, thank you for tuning in to the February edition of the AppSec Stats Flash. I wanted to add a quick vote of thanks to the production team for this podcast, Herman Yip and Lauren Johnson. Thank you for making this easy to do.
Thank you for listening to White Hat Security's AppSec Stats Flash podcast. To learn more, download the report or visit us on the web at www.whitehatsec.com.